The next conic we're going to look at is the ellipse. So again, up here at the top, you're going to see a geometric definition for what an ellipse is. So it says an ellipse is a collection of points in the plane, the sum of whose distances from two fixed points called foci is a constant. So basically what that's saying is that if we have some point out here in the plane, then the distance from that point to each of these foci, if you take the sum of those distances, it's going to be the same for any point that you pick on the ellipse. Okay. All right, so the important part for us though is just all the different features that we're going to look at in terms of the ellipses. So an ellipse is basically just an oval, if you will. It's an elongated circle. So with these, we are going to have, to start with, our center, which of course is right at the middle. And then we have two different axes of symmetry. We have the minor axis, which is going to go through the shorter direction of the ellipse, and we have the major axis, which goes through the longer direction of the ellipse. And we can have an ellipse whose major axis is either horizontal or vertical. That's just going to depend on the equation. So in this one, we have our major axis, which is horizontal. But again, that's just dependent on which direction of the ellipse is longer. All right, and then of course we have two foci for these. Okay, so we'll have two foci that set sort of inside the ellipse along that major axis. And then the vertices are going to be the points, in this case to the left and right of the center, again along the major axis. Okay, and then we have these 2 points here at the top and the bottom. And these don't have a fancy name, they're just called the points on the minor axis. Okay, so if we then look at our equations here, basically we have two different equations for an ellipse. So notice on these, they kind of look like the equation of the circle. The main difference is we, instead of having equal to an r squared value, we have our x minus h squared over a squared, y minus k squared over b squared, where a and b are going to be different numbers. If a and b were the same number, then you'd just be looking at a circle. Okay, now one condition that we have to satisfy with ellipses is that the a value is always greater than the b value. Okay, a is always greater than b. So with both of these equations, the h and k is going to tell us the location of the center. And then since a is always the bigger value, basically the location of the a, whether it's under the x squared term or whether it's under the y squared term, that's what's going to tell us whether our major axis is horizontal or vertical. So if the bigger number is underneath the x, then the major axis is horizontal and the longer direction of the ellipse is horizontal. Where on the other hand, if the a squared is underneath the y, then the major axis is vertical, so the ellipse is taller than it is wide. Okay. A couple other things in these equations. So the a value is always going to tell us the distance from the center to the vertices. So from the center to the vertices, that distance is a. The b value tells us the distance from the center to the points on the minor axis. So from the center to the minor axis, that distance is b. Now, using this equation right here, b squared is equal to a squared minus c squared. Okay, this equation is always true for ellipses. That c value that we can find is going to tell us the distance from the center to the foci. So from the center to the foci, that's the c value. Okay. All right, so keeping all that in mind, let's go ahead and take a look at a few examples. So let's start with example 1. We want to analyze and graph the equation. Okay. All right, so to start with, I want to figure out what my a and b values are. So I'm just going to rewrite this. So in these equations, notice it's always a squared and b squared. So I want to start by rewriting the 16 and the 4 as a quantity squared. Okay, so of course 16 is 4 squared, and 4 is 2 squared. Okay. All right, now remember, A is always the bigger number. So in this case, A is equal to 4, and B is equal to 2, all right? So because the larger number is underneath the x squared term, that means our major axis is horizontal. Okay, because the larger number is underneath the x, the major axis is horizontal. Okay, so now let's find our center. So the center comes from the h and k with ellipses. So since it's just a plain x squared and a plain y squared, that means our center is at the origin at 0, 0. Okay. From the a value, we can find the location of the vertices. Now, sometimes it's easier to find some of these points if you kind of do it as you graph it. So I'm going to go ahead and just start graphing my equation here. So we've got our center at 0, 0, and we said our major axis was horizontal, which means the minor axis is vertical. Okay, so this is our major axis, and this is our minor axis. Okay, so all of the vertices and all of the foci are going to be along the major axis, and then we'll just have 2 points up and down along the minor axis. Okay, all right, so our vertices are just going to be 4 units to the left and right of the center. And we know we're going left and right because our major axis is horizontal. So 4 to the left and 4 to the right of our center, we're going to get our vertices at -4, 0, and +4, 0. Okay. All right. From our B value, we're going to get the points on the minor axis. Okay, so points on the minor axis. So that means from the center, we are going to go up 2 and down 2. And that'll give us the points 0, -2, and 0, 2 on the minor axis. Okay. All right, so then the last thing we need to find are the foci. So for that, we use this equation right here. B squared is equal to A squared minus C squared. Okay, B squared is equal to A squared minus C squared. So plug in your B squared and your A squared. That would be 4 is equal to 16 minus C squared, which means C would be equal to the square root of 12, or 2 root 3. Now, since we're plotting these points, we might as well go ahead and get this as a decimal. So if you plug 2 root 3 into your calculator, you're going to get about 3.46. Okay, so from the C value then, we can find the foci, right? Those are also going to be along the major axis. So to the left and to the right of the center, we're going to go out 3.46 units. And of course, just do the best you can to approximate the decimal when you're graphing these. They're in there. Okay, so 3.46 units to the left and to the right. So we're going to get our foci at -3.460 and +3.460. Okay, and then the last thing to do is just to connect your points, and we have our ellipse. Okay. All right, let's take a look at another example. Let's go to example 2. So x plus 3 quantity squared divided by 9 plus y minus 1 quantity squared divided by 25 is equal to 1. Okay. All right, so looking at this, again, we know that we always have an a squared and a b squared in the denominators. So we want to think about the square roots of these. And always remember that the a value is the bigger number. So in this case, the 25 is the bigger number, so that's going to be our a. And the square root of 25 is 5. So a is equal to 5. So then from the 9, we'll get our b, and the square root of 9 is 3. Okay. All right, so since the bigger number is underneath the y, that tells us on this one that our major axis is vertical. Okay. All right, the center comes from the h and k. So our h and k, and as usual, take the opposite of the factors. So the center is going to be at -3, +1. So -3, +1 is our center. Okay. And let me just go ahead and sketch in my axes here. So major axis is vertical, minor axis is horizontal. Okay. All right. Now we need to find the vertices, the points on the minor axis, and the foci. So from our A value, we can find the vertices. And those are going to be from the center along the major axis. So from the center, I'm going to go 5 units up and 5 units down. And that's going to give me my vertices. So those are going to be at the points -3, 6, and -3, -4. Okay. From the B value, we get the points on the minor axis. So that's going to be left and right of the center. We're going to go out 3 units. So 3 units left, 3 units right. We get the points at -6, 1, and 0, 1 for the points on the minor axis. Okay. All right, and then the last thing we need are the foci. So we'll have to find our c value for that. And again, we're going to use the equation b squared is equal to a squared minus c squared. So plugging in our b squared and a squared, 9 is equal to 25 minus c squared. So our c would be equal to 4. Okay, and again, that's going to help us find the foci. So foci are along the major axis. Right, so from the center, I'm going to go up 4 units. And down 4 units. And that'll give us our foci. So those are going to be at the points -3, 5, and -3, -3. And then the last thing to do is just connect our points. And we have our ellipse. Okay. All right, guys, I'm going to go ahead and stop this video here, but we'll do a few more examples in the next video.